Good morning, children. Stay safely at home and do the study related work properly, honestly in time. So the next chapter is work, energy, power. Now the first few topics that I'll discuss already you studied in 10th standard. So we are just recapitulating that concept. So according to our concept, what is work done? If you consider that a force F is applied on a body and the body undergoes displacement by making an angle theta with the direction of the force, then work done is defined as dot product of force and displacement. Alright, we have already learned it. So you see, you can write what will be the work done. It will be Fs cos theta. So work done, it is nothing but dot product of force and displacement. So work done is a scalar quantity, alright, because it is a dot product of, although force and displacement are vector quantity, but work done is a scalar quantity. Why? Because it is dot product of force and displacement and it is given by Fs cos theta. So you see, the first case that if you consider theta is equal to 0 degree, means what? Force and displacement, they are in the same direction. Then you see what will happen? Work done will be F is cos 0 degree. Cos 0 degree is plus 1. So what you can say that work is done by the force and work is done by the force, and not only that, work done is maximum. Is that clear? In this case, when force and displacement they act in the same direction, then work done by the force. Who is doing the work? Force is doing the work and work done is maximum. Then second case, very important, if you consider that force and displacement they are perpendicular to each other. Theta is equal to 90 degree. Then you see what will be the work done? Fs cos 90. Cos 90 is how much? 0. So when there will be no work done, this is the first condition. No work done condition is if the force acts perpendicular to the displacement. What is the practical example? That force acts perpendicular to the displacement. Already we learnt about the two example. Means suppose you are carrying a heavy school bag and you are working on the horizontal surface against gravity. Is that clear? So gravity is pulling you down, but you are moving perpendicular to the direction of the gravitational pull. So what is the work done? In this case, by gravity it is 0. Work done will be 0. Another one, if you consider the concept of the centripetal force, I hope you can remember. This one you don't have to draw, just remember it. You know, at any instant of time, what is the direction of the centripetal force? Towards the center of the circle. And at any instant of time, what is the direction of the displacement and velocity? Tangent drawn to it. So what is the angle between them? 90 degree. That's why when a body undergoes, when a body move under the action of centripetal force, in that case also work done by the centripetal force is 0. Why the work done by the centripetal force is 0? Because centripetal force acts perpendicular to the displacement. Another point, when a body moves over a circular path, then the displacement is also 0. That's why work done is 0. Then the third condition or third probable case is that theta is equal to 180 degree. Just you consider, when a body is thrown up, the displacement is in the upward direction, but the force is acting, gravitational force acting in the downward direction. So what is the angle between them? 180 degree. In that case, what will be the work done? Fs cos 180. What is the value of cos 180? Minus. So you see, it will be work done will be negative. Negative sign indicates what? Negative sign indicates that work is done against the force. Okay, work done is against the force. Alright, so this is the implication of the negative sign. So these are all the three important cases related with the work done. Nothing new to you. Already 10th standard you studied. Just again you repeat the same concept. Next concept is what are the units of work done. We already know that CG is unit of work done is known as arch, isn't it? Now how you can write 1 arch? 1 arch is equal to 1 dyne into 1 centimeter into cos 0 degree. Alright, how you can define 1 arch then? If 1 dyne force displaces a body by 1 centimeter along the direction of the force, so work done will be 1 arch. Verbally I am saying, I am not writing it because already you know. So I repeat how to write. When 1 dyne force displaces the body by 1 centimeter along the direction of the force, then work done is equal to 1 arch. Then what is SI unit of work done? Very important. SI unit of work done is joule. Alright. So you can write 1 joule is equal to 1 Newton into 1 meter into cos 0 degree. So how you can define 1 joule? When 1 Newton force displaces a body by 1 meter along the direction of the force, then work done is 1 joule. So you see 1 Newton is 10 to the power 5 dyne and 1 meter is 100 centimeter. So you are getting 1 joule is equal to 10 to the power 7 arch. So these are the concept of units of different units of work. Now if you consider the force versus displacement graph, alright, it's very important in physics. Means you are plotting force along y-axis, displacement along x-axis. Now if the force is a constant force, then you see what will be the nature of the graph. Nature of the graph will be like this. It will be a straight line parallel to the displacement, because you see for the displacement is increasing, but what is happening to the force acting on the body? It is constant. So it will be a straight line parallel to the displacement graph. Now what does it graphically represent? Now you see, if you consider the graph under this time, suppose this is the displacement 0 and here is the displacement x. Alright, then you see here what is the area of force versus displacement graph. Area of the force versus displacement graph, from this relation you can write it. Suppose it is C, it will be OA into OC. Now you see what is OA? OA is the force applied on it, and what is OC? OC is the displacement, isn't it? So you see force into displacement is nothing but work done. So this is the concept, that area under force displacement graph gives the measure of the work done. Is the point clear? What I said, I repeat it. Area under force displacement graph gives you the measure of work done. So if the force is not constant, if the force is variable, so suppose you have plotted a variable force, in that case the graph may be like this. In that case, how you can find out what will be the work done? Choose 2 points on the graph, draw perpendicular on the displacement line, displacement axis, then this is the area under the graph. So if you consider ABCD, ABCD will give you area of ABCD. It will give you what? It will give you the measure of the work done. So graphically, by plotting force versus displacement graph, one can calculate what is the work done. So I repeat, how to calculate work done? Work done is equal to area under force displacement curve, alright, or graph. How to draw the area under force displacement graph? Already we have done it, that you choose 2 points on the graph and then from the 2 points you draw perpendicular on the displacement. So you will get a closed area. Find out the area of that closed portion, that will give you the amount of work done. Alright, now you see, if you apply the concept of the calculus, then what we do, we consider that the entire path is, when the force is variable, then we do it. We consider the entire path is broken into small interval dx. Dx means d and x together, derivative of x. So you see, for that small displacement, force is constant. So you can write the small work done dW is given by force into the small displacement. So what will be the total work done? You have to integrate both sides. Alright. So it will be integration 0 to W, and here what will be the limits of integration? X1 to X2. Now integration 0 to W is W. So one can write that work done is given by, this is the calculus method, work done is given by integration x1 to x2 f dx. Alright. Now this part, if you do not understand, there is no problem, because you don't have to solve the numericals related with it. And when you will learn about the integration and derivative in maths class, it will be more clear to you. Just remember the formula that W is equal to integration x1 to x2 f dx. Now the next concept is conservative and non-conservative forces. Now conservative force, already I discussed this topic. Conservative force means what? The force which the work done by the force is independent of the path. It depends on the initial and final position. Just you consider the concept of the gravitational force. Alright. Now suppose you have one body here and you have taken the body to this height h. Alright. Now in the two ways you are taking, that you are directly lifting it from A to B. Alright. Then you see what will be the work done. We know mgh. Alright. Now suppose one has taken from A to B through this staircase. Alright. Here the body is here and the body is taken to the point B through the staircase. Then in that case also, you see what will be the work done? Work done will be mgh. So what is the comment you can make? That work done by the gravitational force depends on h. Means what? Initial and final position. It does not depend on the path. Alright. So gravitational force is a conservative force. So this is the first condition for a force to be conservative. Means the force, work done by the force should be independent of the path. It should depend on initial and final position. Alright. Then second condition for a force to be conservative. If you consider this body, you see here, when you are taking the body from A to B, then work done, actually it is minus mgh. Why minus mgh? Because you are taking it against gravity. Alright. Now, if you take the body from B to A, means you are taking the body along the direction of gravity, then what will be the work done? Mgh. So you see, if you consider the work done over the cyclic path from A to B, then B to A. Alright, what will be the work done? You can find it. It will be WAB plus WBA. WAB, how much you have got? Minus mgh, and WBA is plus mgh. So what is the work done? 0. So this also proves that gravitational force is a conservative force. So what is the second condition for a force to be conservative? That work done by the force over a cyclic path will be 0. So I repeat, what are the two conditions for a force to be conservative? First condition, work done by the force should be independent. I am saying it verbally, you must note it down properly in your notebook. The first condition for a force to be conservative is work done by the force depends only on the initial and final position, does not depend on the path followed by the body. Is that clear? This is the first condition for a force to be conservative. Second condition for a force to be conservative is that work done by the force over a cyclic path is 0. Alright. So as gravitational force satisfying all this, so it is a conservative force. And we know that, I hope you can remember the law of gravitation. Gravitational force acts along the line joining the center of the two bodies. So this kind of force, gravitational force, electrostatic force, these are also known as central force. Alright. Now all the central forces are conservative force. Central force means what? When the force acts along the line joining the centers of the two bodies, then that is known as the central force. Alright. And all the central forces are conservative conservative force because they satisfy both the condition for a force to be conservative. Then the next concept is non-conservative force. Now non-conservative force is the force which do not satisfy this condition. What does it mean? That work done by the force depends on the path followed by the body. Then the force is non-conservative force, and when the work done by the force over a cyclic path is not zero, then also the force is known as the non-conservative force. Now already in the friction chapter I discussed you that frictional force is a non-conservative force, and as it is a very important concept, so I am repeating it again. So you see, if you consider the frictional force, just suppose you have one body was at A and you are dragging the body to the point B. Then you see in which direction frictional force is acting. Frictional force is acting in the opposite direction. So you see, what is the work done by the friction for taking the body from A to B? It will be minus F into D. Why minus F into D? Because you see force and displacement, they are in opposite direction, isn't it? So what is the angle between them? It is 180 degree, and cos 180 degree is minus 1. Just now we have studied. So what is the work done by the frictional force to take the body from A to B? It is minus Ft. Now suppose you are taking the body from B to A. Is that clear? So you see, when you are taking the body from B to A, then you are taking displacement is in this direction and frictional force is acting in this direction. So you see, in this case WBA, what it will be? Again it is minus FD. Why? Because F and D, again they are 180 degree to each other. So if you consider the cyclic path, means A to B and then again B to A. This is the cyclic path. So what will be the work done? It will be WAB plus WBA. Now WAB is minus FD, WBA also minus FD. So you see, you are not getting 0, you are getting minus 2FD. So WAB is not equal to 0. So frictional force is a non-conservative force. So sometimes the question comes like this. Show that frictional force is a non-conservative force. Then this is the derivation you have to do. You just draw this diagram and write it down. WAB, WBA and WABA is not equal to 0. And then you write down the comment. Therefore, as work done over the cyclic path by the frictional force is not 0, so frictional force is a non-conservative force. So this concept of conservative and non-conservative forces are very, very important for your exam, any kind of exam. Concept wise also it is very important. So kindly learn it and remember it, practice it. Now next concept is energy. Now energy is what? I hope you can remember. Ability to do a work is known as energy. That's why energy is always measured by the work done. Energy is measured by the work done. That's why SI unit of energy, or rather units of energy, is same that of work done. Then another important concept regarding energy is that energy we cannot create, we cannot destroy, we just convert it from one form to another. It means that energy have different forms. Out of that, the most important form is the mechanical energy. And again, you know, mechanical energy, there are two types, kinetic energy and potential energy. So I am going to discuss now what is kinetic energy. Kinetic energy is the energy possessed by a body due to its motion is known as the kinetic energy. Now how you can measure the kinetic energy? This is the way you can measure. Suppose a body of mass M, alright, moving in this direction. Let us consider the body is moving in this direction with a velocity v. And a force is applied in the opposite direction. Force is applied, look at the direction of F and V. F is applied opposite to the direction of motion of the body. So what will happen? The body, after moving certain distance, the velocity will become equal to 0. So let us consider the body undergoes a displacement S along this direction. Alright. So you see, in this case, what will be the kinetic energy? kinetic energy will be equal to work done to stop the body. Is that clear? Either you can say when you are creating motion in the body, then it will be work done to create that motion, and when you are stopping a moving body, then kinetic energy will be the measure of work done to stop the body. So here we have taken kinetic energy is work done to stop the body. So according to this relation, you see force in this direction, displacement in the opposite direction. So one can write what will be the work done minus Fs. Again, force you can write mass into acceleration. So you can write it as minus m into a into s. Now, according to third equation of motion, what is the third equation of motion? You know, v square is equal to u square plus 2as. Alright. Now here you see, what is the final velocity? 0. What is the initial velocity? V. Then you can write it as 2as. So you are getting as is equal to minus v square by 2. So this is equation 1. This is equation 2. Substitute equation 2 in equation 1. What are you getting? Kinetic energy is equal to minus m into minus v square by 2. So mv square by 2. Is that clear? So that is the expression for kinetic energy. Kinetic energy is given by mv square by 2. This is the relation already you have done in 10th standard. Nothing new. So you see, kinetic energy is half mv square. Now one can write it like this, half m square v square by m. What I have done? I have multiplied in the numerator and denominator by m. I can do it. Now mv, what it is? It is linear momentum. So you can write it like this, mv whole square by 2m, and mv is the linear momentum. So p square by 2m. So this is another relation for kinetic energy, and very important relation. You get conceptual question also on this relation. So kinetic energy is given by p square by 2m. So you see, according to this relation, what is the momentum? Momentum is given by under root 2mk. K stands for kinetic energy. K stands for what? Kinetic energy. That's why if you draw a linear momentum versus kinetic energy graph. What is K? K is the kinetic energy and P is the linear momentum. Linear momentum versus K graph. Then the nature of the graph will be like this. Okay, because P is equal to under root 2mk. So this relation means, actually this is coming from this one only. So either you remember the relation according to this one or this one, as you like. And this is the important graph you have to remember, that linear momentum versus kinetic energy graph. It looks like curve. According to that formula, P is equal to under root 2mk. Now next concept is WorkEnergy Theorem. According to WorkEnergy Theorem, what we know, when a force displaces by a body in certain direction, then work done by the force is equal to change in kinetic energy. Means one can write work done is equal to change in kinetic energy. But remember, in this case there is no change in the potential energy. But if the potential energy also changes, in that case it will be work done is equal to change in the total energy. You must to remember that. If it is only kinetic energy changing, then it will be change in kinetic energy. If only potential energy changing, then kinetic energy is remaining constant. In that case work done will be equal to change in potential energy. And if both potential kinetic energy changes, in that case according to WorkEnergy Theorem, work done is equal to change in total energy of the system. Alright, but in this particular case we are considering that potential energy is remaining constant, so work done is equal to change in kinetic energy. Now how you can prove this one? Suppose a body of mass m was moving with a velocity u in this direction. Now a force F is applied to the body. Now under the application of the force, what will happen to the body? what will happen to the body? The body will undergo certain displacement. Suppose the body is undergoing certain displacement S, and not only that, as the force and the direction of motion in the same direction, so the body will have accelerated motion. So after some time, let us consider the velocity of the body becomes V. So in this case, you see, what is the work done? Work done is equal to F into S. Now, F into S you can write into mass into acceleration. Force is mass into acceleration. So, force is equal to mass into acceleration into displacement S. Now, according to third equation of motion, what you can write here? V square is equal to U square plus 2AS. In this case, V is the final velocity, U is the initial velocity, A is the acceleration, S is the displacement. So, you see, you can write 2AS is equal to V square minus U square. So, AS is equal to V square minus U square by 2. This is equation 2. So, substitute equation 2 in equation 1. So, what are you getting? Work done is equal to M into V square minus U square by 2. So, you can write it as MV square by 2 and MU square by 2. So, look at it. MV square by 2. What it is? It is the final kinetic energy. Mu square by 2. What it is? It is initial kinetic energy. So, MV square by 2 minus Mu square by 2 is nothing but change in kinetic energy. So, work done is equal to change in kinetic energy. So, this is the way one can prove the work energy theorem. Now, next concept is concept of potential energy. So, what is the concept of potential energy? The energy gained by a body due to, there are two conditions for potential energy, due to change in its position or change in its shape. So, when there is a change in position of the body, just you consider this example, that duster is falling on the floor and you are lifting it and keeping it on teacher's table. So, when you are lifting it up, then you are doing work against the gravity and you are changing the normal position of the duster from the ground to the teacher's table. Alright, so in that case, the energy gained by the body is known as the gravitational potential energy, and already we have done it. What will be the gravitational potential energy? It will be the gravitational force acting on the body. What is the gravitational force acting on the body? M into G into the height to which the body is raised. So, gravitational potential energy is given by mgh. Then, next concept of potential energy is known as the elastic potential energy. Elastic potential energy is the energy gained by the body due to change in the shape of the body. Alright. So, just consider this example. Suppose there is a spring and a body is connected with it. Now, you know, whenever, in case of spring, whenever you displaces the spring or you elongate the spring or contract the spring by an amount x, then a restoring force act on the spring. According to Hooke's law, restoring force is directly proportional to the displacement, and why the term is restoring force? It restored the original shape, the original position of the body attached to the spring. That's why it is known as the restoring force. So, if you consider that you have displaced the body by an amount x, in that case you have elongated the spring by an amount x, then the restoring force, it will act opposite to the elongation or opposite to the displacement. So, according to Hooke's law, okay, that again I will discuss in elasticity chapter. According to Hooke's law, one can write that restoring force is directly proportional to the displacement. So, F is equal to minus Kx. This negative sign indicates what? F and X are opposite in direction. Is that clear? So, you see, if you want to elongate the spring, if you want to take the mass through a displacement x, then how much force you have to apply? Force to be applied force to be applied, it should be equal and opposite to F. So you can write it will be K into X. Now what will be the work done? Work done is integration 0 to X F dx. So how much is X F here? Kx. So Kx dx. So integration x dx is equal to x square by 2. So if you substitute the limits, it will come kx square by 2. Now as this part, mathematical analysis part, I have not taught you. So this part, if it is not, you are not understanding, there is no problem. Just remember the ultimate result. What is the ultimate result? That elastic potential energy is equal to work done equal to kx square by 2. This is the elastic potential energy. So remember the result. I repeat, this part you may not understand because the mathematical analysis part I have not taught. That's why this part you do not remember, only remember the result. So what is the expression for elastic potential energy? Elastic potential energy is given by kx square by 2. K is known as force constant or spring constant, which depends on the nature of the material of the spring, and x is the displacement of the spring. Alright, so that's all about the concept of the potential energy. Thank you girls. That's all for today.